Hello, Algebra. This is the last section that we have to cover for our course 10.1 on radical expressions. And the course is officially over with the material. The rest will be all about testing and final and review, and that's it. So just a quick reminder that the stuff that I will be posting on the canvas, there will be a couple of these exams coming up for you to take if you are interested. You took exam 3, grades will be posted if not today then tomorrow, and then I will also plug in exam 1. Exam 2 redo will be exam 2 redo will be given next week, and then exam 4 as well next week, and then the final exam for those of you who want to take the final exam, if you skipped any of the tests or if you missed anything, you need to take the final to replace that grade. Some of you can do the optional, final, but if you take the final, it will count. So we'll deal with that. Let's go and deal with the radical expressions. Please go to Canvas, make sure that you are following the dates and times and everything I post there. So for radical expressions, section is a little bit longer. It involves functions as well, but we are not going to deal with functions. We're only going to take a look at expressions. So we have to learn about the square root, right? Which you guys know. Oops, not sure why I clicked on red. You already know that the square root of 9 is 3, square root of 144 is 12, right? Square root of, let's say, 25 over 100 is 5 over 10, which is 1/2. And the other thing that you can do, if you have 25 over 100, that reduces down if you divide by 25 to 1 over 4. Square root of 1 is 1, square root of 4 is 2. So you can do this problem either way. You can do the problem by canceling, or you can do the problem by taking the square roots and then dealing with this. So whatever way you want. So now we are going to take a look at more of the expression side of things. Let me just mention also, in addition to what we talked about so far, let me just mention that you can also find the square root of numbers that are not perfect squares, but for that you would use the calculator, right? And the calculator would have a button for the square root. Some calculators ask you to put the number first and then push square root button, and some calculators would have you put the square root symbol first and then the number. So just try both ways, depending on which calculator you have. So square root of 31 is approximately, and now when I say approximately, we put the squiggly equal sign, about 5.5678 if you want 4 decimals, right? It's actually 776, but then that 6 will make 7 into an 8 when you round. Therefore, that will be it. So radical expressions, in case of the square root, you can have more than a square root, you can have a cube root and so on, but that's for intermediate algebra. You don't have to worry about it in this course. Now we have to be careful. Square root of a negative number is not a real number. What you would get in this case is something that you will learn in intermediate algebra. So intermediate algebra will say that the square root of -9 is equal to 3i. So that's going to be imaginary value, and that's, as I said, for intermediate algebra. But for elementary algebra, we just say not real number, and we move along. So that's all about square roots. Now, cube root is denoted as a cube root of a value. Say cube root of 8 is, let's say, 2. And what it means is 2 times 2 times 2 is equal to 8. So for the square root, which is when you don't have a number inside, square root is multiplying two same numbers, and the cube root has 3. So technically this is 2 cubed is 8. Previously, over here, 3 squared is 9. So this is what it means. It's just reading the same problem differently. One of the cool formulas is that if you have a number squared and you take a square root of it, right, you will get the absolute value of that number. Because essentially square root and a square cancel because they're opposites of each other. We can try this with, let's say, 4 squared square root. You are supposed to get a 4. Why? Well, if you want to compute this, you will have a square root of 4 squared is 16, and the square root of 16 is 4. Right? So the idea is, and also if you have a square root of 4, everything squared, they still cancel down to 4. Because if you have it that way, then square root of 4 is 2, and 2 squared is 4. So it doesn't matter in which order you put them. And those of you that are interested in more computation, especially if you're going to intermediate algebra, when I write a PEMDAS, the square roots are where the exponents are. Later on in mathematics, you learn that the square roots are actually half exponent for a square root, 1/3 as a cube root, and so on. So you would write them also as exponents, but exponents will be in terms of fractions. So when you're dealing with PEMDAS, square roots and exponents are in the same category. So parentheses first, and then you would do a square root or whatever root you have, and then you would do multiplication, division, and so on. So we have the cube root and we have the square root. So I just want to jump into exercises. They say only first 4 examples. They're not going into functions later on. So we're just going to jump and work on the problems. Let me just see. So on page 658 and 659, problems 1 through 58. And we are not dealing with the rest. So 59 through 100 and whatever are all through 102, I guess. They're all about functions. And we're not dealing with functions in this course. That's the job for intermediate, little bit, and then pre-calculus 1, obviously. So these are the problems. Let's take a look at some of the random problems over here. For instance, they're asking you how much is the square root of 0.64, and that's 0.8. So that was problem 18. They're asking you to calculate in problem 25 cube root of negative 64, and that would be negative 4. You see, the square root of negative 64 is not real. Square root of 64 is 8. And the cube root of negative 64 is 4, and the cube root of 64 is 4. So just have to be careful with all of the different, right, whether it's a cube root, the cube roots preserve the sign, and the square roots or any other even root, they cannot be taken from the negative numbers. I mean, they can, but it's not a real answer. It's complex. It's imaginary answer. What else do we have? Problem 31 looks good with a cube root of 27x to the 3. Okay, that's cube root of 27 times the cube root of x to the 3. So what do we have? Cube root of 27 is 3, and over here, because they are the same powers, they cancel, so we just get 3x. Really cool. Let's take a look at 32 as well. This is pretty much the same. So I have cube root of 2 to the 6 times cube root of x to the 6. Because remember, this exponent, by what we learned in chapter 5, or 4, or 5, this exponent of 6 applies to both 2 and x. So, when they cancel, we get a 2, and we get 2 squared times x squared, which is 4x squared. Problem 37. Fourth root of negative 16, not real number, because it's even root for the negative. So anytime we have even root of a negative number, we get no real or not real number. It should say not real. There we go. Then they say use calculator. And you're supposed to find square root, problem 40, negative square root of 5. And they say nearest hundredth, that's 2 decimals. So copy the negative and then 2.24. If you do square root of negative 5, then that's not a real number. So be very careful, right? In the first problem, right, problem 40, we don't have a negative under the root. Negative is outside of the root. So we copy the negative and we have a positive number inside the even root. Okay, there goes, that works. But if you have a negative number inside the even root, it's not a real number, so you have to be careful. Now, what do we do for problems with the cube root? So most of the calculators only have a basic square root button. Now, some calculators might have something that looks like this as a button, or maybe like this. But most of the calculators will have this little hat symbol like this. this is exponent. So if you want to type in, let's say, 9 squared, you can push the button with a 9. Then you can push the button with this little hat or a caret. It's also known as caret. And then you can push the button with a 2. And when you push enter, it will give you 81. How do you press 1 over 3? I mean, cube root. Cube root is going to be exponent, as I said before, of 1/3. So you will go and you will type -13, and then you would push the caret, and then in parentheses 1 divided by 3. So if your calculator doesn't have these, one of these two, because that just follow what's what, and that goes for all of these that have exponents. So if you have a cube root, then you can just plug in numbers. And if you only have this button on the calculator, then you can convert your cube root into 1/3 exponent, and then you can use it. So let's see, problem 44 is a 4th root of 6. So you will plug in 6, then you would put actually let me write first, this is 6 to 1/4 exponent. So in the calculator, you would push 6, you would push a caret, then you would open a parenthesis, then you would push 1 divided by 4, and then you would close the parenthesis. So that's how you can type in a quarter. Some people that know that 1 divided by 4 is 0.25, you can also type in 0.25 or just 0.25. So 6 raised to 0.25 will give us approximately 1.57, because they said 2 decimals. Good. Couple of more examples, and then I'll get to the chat. Problem 46 is asking you to simplify 9 squared. So when they cancel, just get a 9. Problem 50 has the square root of 2x minus 1 squared. And we said that we were going to get 2x minus 1 in absolute values. Problem 55 is 4th root of x to the 12. That simplifies down to absolute x cubed, because 12 divided by 4 is 3, right? Exponent of the exponent. And we can do one more. I mean, when the exponents are the same, here 56, when exponents are the same, they just cancel, right? That's a 6th root of x to the 6 is just absolute x. 6 divided by 6 is 1. So nothing special there. And I think that's it. That's the extent of how far we go with 10. That's only half of the lecture, 10.1, because the other half is on functions, and that's reserved for intermediate algebra. And anyway, and that's the course. That's it. That's it for elementary algebra. Exam 4 will only have these 4 sections that we covered here, which the what is the chapters 7 and 10. So I believe it's only 4 sections, right? Yep, 7, 1, 2, 3, and 10. So it's only 4 sections. Chapter 4 exam will be a little bit shorter than what you guys are used to because we only have 4 sections. I mean, I can still plug in 10 examples, but we don't really have a huge amount of, so maybe even shorter, maybe down to 40 minutes or something like that. Very quick. And then, so that will be exam 4, and that's going to be on, I'm going to post all of the dates and everything in announcements, so please go there and just read everything carefully 15 times if you need to, just to make sure that it makes sense. It will be clear the options that you guys have this semester during the mess we were in. It will clearly explain what's happening with the final. It will clearly explain about exam 2 retake. So I just need you to read those things carefully. Make sure you understand them all. So that's all going to be in announcements on Canvas, and that generates the email to you as well, so you won't be missing it unless you're obviously not checking anything. Then, right? Then I start getting emails with questions and things that are already explained. So just make sure you read everything. I'm going to leave right now and post all of that stuff this moment. So it will be there by 4 p.m. today latest. I have to type everything out. All of the dates, all of the times, all of the exams from now on are on Canvas. Some of you were not paying attention last time at all, did not read any of the emails or anything, and then you were looking for exam on MyMathLab, and right. So be very thorough in reading emails and responsible. Obviously, it's the part of being an adult. And I am going to post everything about, yes, there will be quizzes for exam 4. So, and all of the homework will be reopened for you to practice towards the final. So all of that stuff will be spelled out for you. So I hope that you will read those announcements carefully and participate as much as you want, meaning taking all the exams that you want to take. So there will be exam 4 is first, then there is exam 2 redo for those of you who want to take it, and then there will be a final for those of you who either must take it or want to take it. And I will spell out the difference between must take it and want to take it in the announcements. So, as I said, I'm going to take about 30 minutes now to type all of that out, make sure everything is correct, all the dates are there, and all the dates sync with both MyMathLab and thing. I'm going to also post the file with the final exam review. I will also mention that will be in Canvas, obviously. The file that it's the official department final exam review file. If you're looking for more practice and stuff, right, you can use that file. Go to Canvas where the syllabus is, you download the file, open it up on a computer and just stare at it, right? Do problems on a paper. That's just extra practice. So very important to not to miss these announcements coming up on Canvas. So that's it for now. The course and the lectures are over. Entire next week will be office hours only. I will be online. And if any one of you joins in and asks a question in a chat or sends something in a question in an email or something, I will be answering those. We are done with our last lecture. So the next week is just exams and reviews. So 4 reviews. That could be 4 hours of review time if you ask questions, or 4 hours of silence and me clicking my video game because I have nothing to do. So please make sure you are asking questions, prepping your questions. I'm going to post quizzes, obviously, for exam 4. So that's all due for next week. So I'll see you all the dates we talked about last time. I'm going to post all of that on, and then if you guys have any extra questions and things, make sure you ask. Bye.